Hey, welcome back to RamZland. Today I want to show you different colors of plasma. Check this out. To begin, when my high frequency generator is close to the bolt, you'll see that most of the plasma generated is purple in color. But it's purple because over 70% of our atmosphere is nitrogen. Okay, so now we want to see if we can excite some of the electrons in lithium chloride to release photons that have a wavelength that appear pink through the light spectrum instead of purple. Let's try it out. Oh yeah, it's definitely looking more pink. Pink plasma with lithium. Just awesome. Okay, instead of using lithium chloride, this time I put a little bit of copper chloride in the bottom of the test tube here. And I'm going to hit it again with a high frequency generator and see if we can generate some green plasma. Check this out. Okay, so what's going on in this demonstration is that you're ionizing gas. That's all the plasma is. And so when you saw that purple plasma, that was because of nitrogen in the atmosphere. When you get electrons excited, they move to their outer energy level, and when they return to their original orbital, each electron gives off a photon. A photon is a particle of light, and each photon has a different frequency and a different wavelength. Now, if their wavelength is between 400 and 700 nanometers, we can actually see those as colors through the light spectrum. So when you saw the nitrogen appeared to be kind of purple, you were looking at a wavelength of a photon that was closer to 400 nanometers. Remember, a nanometer is just a billionth of a meter. And then when we use lithium chloride, the color changed. Well, that's because when lithium gets excited, it emits photons that are closer to 650 nanometers or 700 nanometers, appearing to be pink or red through the light spectrum. And then when we use copper chloride, that color turned to green. And that's because it was releasing photons that were closer to 600 or 550 nanometers in wavelength. So remember, when a wave gets longer, it's less dangerous, kind of like radio waves. But when waves get shorter, they become more and more dangerous, like X-rays or gamma rays. Well, I hope you enjoyed today's edition of RamZland, and I'll see you next time.